y is dy dt. And v sub z is dz dt. Assuming x, y, and z are positions, like we have over here. Now, what I want to derive here is the relationship between this Vy in the prime frame and Vy in the S frame. So Vy prime would be dy prime over dt prime. Well, I know y prime is just y. Because again, we have this thing moving in the x direction, so the prime frame is moving in the x direction. So this is just dy over dt prime down there, which is gamma t minus v over c squared x. That's t prime right there, just t prime. Which is dy over, well, I'm doing a derivative of this right here. Gamma is a constant, so it just pops out. And I'm left with dt minus dvx over c squared. In essence, it's sort of distributing the d. Officially, it's not distributing. So dt is just dt, so this is dy over gamma times dt minus, well, v is how fast, probably should use the same letters I was using before. Call that, sorry, I'm gonna make that u. That's u. So s prime is traveling, so I'm just do u. U is a constant. This thing is just moving off to the right at some constant value. C is a constant, and so what I'm left with is just dx. Multiply top and bottom by 1 over dt. So on top, I get dy dt over gamma times 1 minus u over c squared dx dt. And so dy dt, that's just how fast the thing's going in that direction. So this is Vy over gamma 1 minus u Vy. Oh, sorry. Yeah, that's x. So u Vx over c squared. So we have a way of calculating how fast this object is moving up in the prime frame relative to this frame right here. So doing a quick plug and chug here. So if from S's point of view, S point of view, the thing is traveling at 0.6 speed of light that way and 0.8 speed of light in that direction. Actually, that can't be. I get 0.3 and 0.4. So from S's point of view, it's traveling like that. Then from his front point of view, S prime point of view, in the same direction that's traveling, we just went through that formula. This would be that minus that, so Vx prime would be Vx minus u over 1 minus UVX over C squared. And Vy prime would be Vy over gamma 1 minus UVX over C squared. And I want that? Yeah, I do want the gamma there. Well, this, yeah, I think I need to be more specific on U, because that gamma is gonna mess us up. So this would be 0.3 C minus, let's make this 0.1 C, minus 0.1 C, divided by 1 minus 0.3 times 0.1, which is 0.2 C over 0.97. I made the speeds too small for anything dramatic here. Where is it? And this would be Vy, which is 0.4 C, divided by gamma, which is gonna be somewhere close to 1. It's 1.0. There it is. Let's get to 1. 5 times 1 minus 0.1 times Vx, which is 0.3. So 0.4 C divided by 1.005 times 0.97. Whatever that is again. So just a slightly off of what we had before. And did you do a calculator on it? No. Yeah, I should get the numbers.
Okay. 0.4103 C. That's just rounding.
The other one? Wait, 203?
What is that second number under 4C? For 0.4C?
Pardon?
What is the second number under 0.4C?
That's 1.005,
The second one?
0.97.
Oh, sorry.
I got 0.2062 C.
So you're changing your 0.413?
That's
No,
what
no,
I-
no, no,
that's
that's
what
what-
I'm all-
Okay. And so from the prime frame point of view, it's traveling point. This object is traveling at a little more than 0.2 times the speed of light to the right, and a little more than 0.4 times the speed of light upwards. Not because the distance in this direction has changed, but there is a time difference between the two. And this equation right here will simplify the next step greatly. Questions? All right, don't forget Wednesday, quiz on chapter 37. Wednesday.
So I need to stop this for you.
Yeah, you can stop.